Hey everybody, welcome back. In this lesson, we want to talk about types of radiation, or in other words, ways of categorizing radiation. Every type of radiation can be categorized as a photon or as a particle or particulate radiation. Each type of radiation can also be categorized as ionizing or non-ionizing. And finally, the third classification is being charged or uncharged. And of course, with any individual type of radiation, the categorization may be a little different. For example, you can have a type of radiation that is a photon, so that means it's a wave, it's ionizing, and then of course it's uncharged because all photons are uncharged. Or you could also have a photon radiation that is non-ionizing, like radio waves, and once again, it'll still be uncharged because all photon radiation is uncharged. Here's another scenario. We could have a form of particulate radiation that is ionizing because all particulate radiation is ionizing and it has a charge, like alpha radiation, beta radiation, and other forms of charged particulate radiation. And here's another scenario. We could also have particulate radiation that is ionizing because all particulate radiation is ionizing, but it's uncharged. So what particulate radiation would be uncharged? That would be neutrons. So let's talk about each of these categories in more detail. To start with, particulate radiation versus photon radiation. All types of radiation fit into one of these two categories. It's either a particle or it's a photon. Particulate radiation includes alpha particles, beta particles, electrons, protons, neutrons, in fact, all of the subatomic constituents, and even fragments of atoms can sometimes be broken off of the parent atom and be transmitted through space as a form of radiation. So literally any type of radiation that is a physical particle that has mass and is being emitted from a source is particulate radiation. On the other hand, we also have photon radiation. And this, of course, includes the entire electromagnetic spectrum, which is X-rays, gamma rays, visible light, ultraviolet light, infrared rays, and the other types of photon radiation that are on that spectrum. They behave like waves, and they exist only at the speed of light. So every type of radiation is either a particle or it's a photon. Another way that we can classify radiation is as ionizing or non-ionizing. This categorization is actually pretty simple. Some types of radiation are ionizing, which means they have enough energy to knock electrons out of their orbit. But then, of course, there's other types of radiation that are non-ionizing. They just don't have enough energy to knock electrons out of their orbit. So we can see several types of radiation are ionizing. Let's look at an example of how that works. We'll start with a neutral atom. Doesn't matter what kind of atom this is. We'll say it's a calcium atom, but this can be true of any atom. So we'll say it's a neutral calcium atom. It's neutral, electrically neutral, because there's the same number of protons and electrons. So they cancel each other out, and overall it has no charge. But if an X-ray photon strikes an electron within this atom, it can knock it out of orbit. That's called ionization. And so what we would be left with is an atom. We'll still have an atom, but it's missing an electron. So now it has a net charge of +1. And then, of course, there's that free electron flying around now out in space. So there's another ion, and it has, of course, the charge of all electrons, which is 1-. So this is the idea of ionization, when an ionizing radiation knocks an electron out of orbit and creates these two ions, a positively charged atom and that free negatively charged electron. So this can happen on the atomic level. That's how ionization happens, is on the atomic level. But you can also think of it in terms of molecules. So let's say we've got this neutral water molecule. So in total, this molecule has no charge. It's electrically neutral. It's got a lot of positive and negative charges in it, but in total, it's neutral. But the same thing can happen. Let's say that this neutral water molecule is struck by an X-ray photon, which is a type of ionizing radiation. The same thing's going to happen. It'll knock an electron out of its orbit, but in so doing, it will actually break apart the entire molecule and create two separate charged particles. In this example, we'll end up with what we call an hydroxyl ion, which is an oxygen and a hydrogen together with a negative charge, and also a free hydrogen ion, which has a positive charge. So we start out with a neutral atom, and through this ionizing interaction, the molecule breaks apart, and we have a positive ion and a negative ion. So that's the idea of ionization. So what types of radiation fit into each category? Once again, remember that ionizing radiation has enough energy to liberate electrons and create these charged particles. This includes all of our particulate radiation, such as alpha particles, beta particles, electrons, protons, not photons, but protons, and any other particle that's emitted as radiation. All particles are ionizing, but there's also some photons that are ionizing, which is why we have a photon on this side of the graph. So ultraviolet light, X-rays, and gamma rays are all forms of ionizing photons. But then we also have some non-ionizing radiation, and notice that it's only a portion of the electromagnetic spectrum. There are some photon radiation or wave radiation that don't have the ability to ionize. And this includes everything from visible light and downward. So that's going to be visible light, as well as microwaves and radio waves. All of these are forms of radiation, but they don't have the ability to knock electrons out of its orbit. So when you look at the electromagnetic spectrum itself, this is how you can divide it. Ultraviolet light, X-rays, and gamma rays are all ionizing. They can knock electrons out of their orbit, but everything else, visible light, infrared heat, microwaves, radio waves, are all non-ionizing. Still potentially dangerous, but not ionizing. Let's look at our last way of categorizing radiation, and that is charged or uncharged. And I think this one's very straightforward. A charged radiation is literally any kind of radiation that carries a charge, an electric charge, such as alpha particles, beta particles, electrons, positrons, protons, anything that carries a net charge. And these charged particles interact in matter in a very unique way. The thing you should know is they rapidly deposit their energy in matter. Just as an example, an alpha particle can only travel just a very, very short distance, even through air. An alpha particle deposits its energy so rapidly, it only travels a few centimeters in air. And then, of course, we have the uncharged radiation. This includes one particle, which is the neutron. It's neutral. It has no charge. But also, the entire electromagnetic spectrum should be considered uncharged because all photons have no charge. Let's take a second to look at how these different types of radiation interact. In this first illustration, what we're looking at here is all of the electrons spread out inside of matter. All matter includes electrons. Radiation commonly interacts with the electrons, not so much the nucleus, more so the electrons. So what's going to happen if we send a positively charged alpha particle into this mass of negatively charged electrons? Well, in this illustration, you can imagine what's going to happen. The positive charge of that alpha particle is going to attract the negative charge of all of those electrons. And that's why we say that charged particles, like alpha particles, interact very rapidly and deposit all of their energy very quickly. They can't make it very far into matter before they've collected all these electrons and they've deposited all of their energy. And the thing here that's interesting is notice how their electric fields, the electric fields of these charged particles are interacting with each other. They don't have to physically touch. The alpha particle doesn't have to physically run into an electron to interact with it. It just has to be close. And that's why, like when an alpha particle or a beta particle enters into matter, it is immediately and continuously interacting. So here's another example. This time we'll use an X-ray photon. An X-ray photon is uncharged. It doesn't have an electric field like these electrons or like an alpha particle, and so it must collide with something in order to interact. And so in this illustration, the X-ray photon has made it all the way through to the very last electron where it finally interacted and ionized or knocked out that electron from its orbit. So the way they interact is completely different, but both charged and uncharged can sometimes be ionizing. Now let's take a second to test your knowledge, look at every form of radiation that we've discussed, and try to fit it into the correct category. Take a second to do this on your own, and then I'll give you the correct answers. All right, hopefully you did this on your own. X-rays are a form of photon radiation. They're ionizing, and like all photons, they're uncharged. Light is also a type of photon radiation, but it's non-ionizing, and of course, it's uncharged. Alpha radiation, completely different. It's a particle, so it's particulate radiation, but like all particles, it is ionizing, and it does have a charge, has a charge of +2. Radio waves are a type of photon, but they're non-ionizing. And like all photons, they don't have a charge. Beta radiation is a particle. Like all particle radiation, it is ionizing, and it does have a charge of 1-, just like an electron. Gamma radiation, identical to X-rays, basically. It is a photon radiation, it's ionizing, it's uncharged. Finally, neutrons, they're pretty unique. Neutrons are a form of particulate radiation. They are ionizing, but they do not have a charge. So this particle, the way that it interacts is really strange, really different than our other charged particles. So that's an overview of how we can classify different types of radiation. Thanks.